Nakama, how are you today? This video is about function. Okay, it is a relatively big video, so I want to go a little quickly. So let's create function.c. Include std and my function main. Okay, firstly, the description. We have already talked about the definition or declaration about function. I think it's here. Yeah, it's here. Layout of a C program. We have declaration about function here. The declaration, but we will start with definition. Okay, you will see because we will start with definition. So definition of a function: type, name, and then argument. Okay, argument or parameters inside here and the statement inside. So type is a returned type. Okay, so let's go back here to write it again. Return type. Okay, and function name. Okay, name is function name, and parameter list, a list of parameters inside. And then you have your function body and return value. Yes. Okay, that is the layout of function, of definition of a function. So the advantage of that, we have already talked about it, is to avoid repetitive code. Okay, sometimes we need some kind of code many times in your project. Okay, many times you have a same kind of code, same thing. You do something, you do the same thing many times. So function permits you to name this code. Okay, by give a name, by precise the return type of the function. Okay, of the block of code. Okay, so for example, that is the main function. The function is mandatory. Okay, for your code, for a C program, you always has at least main function. Okay, it is automatically called when you execute your file. Okay, when you execute your executable file. And for example, we can create, okay, let me okay, yes, go. I can create an example here, a function about average. So type name. Okay, and then the name of the function, the name of the function, I call it average. Okay, that's the average. So the function takes two parameters. One parameters, I call it A, type integer, and B, type integer too, and I return A plus B divided by 2. So return is a statement to give you a value. Okay, this value is returned. So it means that this value is going to accumulator. It's a register. Okay, inside your computer. So this value is returned at your operating system, and then you can catch it inside your function, inside your code. So let's try to see the result of that. So for example, I can yes, do a code like that. So I have a variable a, b, and c equal my function. Okay, that is a call function. So you have two ways to call function. You can call function directly, okay, without something like can call the function like that with 10 and 5. Okay, that is a function call, but the returned value is lost. Okay, you don't catch it or you don't print it. You do nothing with it. Okay, it's not efficient like that. So that is why generally we see this form of function call. You do the function call normally here, and then you store it inside you store inside a variable. So you store the returned value. When this instruction means call the function and then the returned value, store it inside this variable. So the result is the result of that. Okay, that is the meaning of return. Okay, function call gives you the returned value. So I print average of a. Okay, the first place here placement is for a. Okay, percent in decimal, you have already explained it, and the second is b, and is okay. The average of this and this is this. Okay, this is c. Okay, c is the result of the average. So if you test it, let me just say this function dot c, and I call it function. I execute my function. Okay, average of 3 and 6 is 4. Okay. So the return value causes to return to the place from which it was called. So like I explained, when you called the function here, this instruction, okay, return the value, okay, the value at this place. Okay, so if I want to print directly, I can do it here, the average of a and b, and here I do just average a b directly like that, without store inside the variable. Okay, so you can print that, because this like we have a returned value inside my function, this function is replaced by the value. That is why I can't store this value, but I can print it. Okay, so you see I have a function inside a function. That is because any function, okay, can return a value if there is the return value. Okay, of course. So let's try it. Average of 3. Okay, same result. Okay, the same result. Arguments are replaced by value where it's called. Yeah, that's why I explained. I have a small to-do list because I have a lot of things to avoid to forget something. I just read my to-do list. You cannot return an array. Okay, for example, you cannot do something like int like that. Okay, you cannot return an array, because array is supposed to be something like that. So you can have, for example, here inside okay, let me show you something. You can have a declaration like int, for example, I don't know, some. Okay, you can just define, okay, definition, for example, int. You just write int and int like that. That is the definition, without precise the name of each argument. It's permit for definition. So you can do it with array. Okay, you can put array like argument. Okay, like that. Okay, it's like that, but you have not seen. Okay, we will come back. I show you how to do it with array. For now it's not important. It's not important now. Let's go to function call inside a function. Yes, I show you can use a function inside a function. Okay, if the returned type is correct. Okay, like here I have precise %d. So it's suppose you have to have an integer, okay, returned by this function. If it's not an integer, they will not print it well. So for example, I can precise I return a float type. Okay, if I return a float type, I say here is float and here is float. Okay, if I don't do it, I take an integer, because return, if you return a wrong type, the alternate type will be automatically okay, I think I can leave like that. Okay, the alternate type will be automatically will be automatically translate to float. Like here I have integer results, but automatically it's converted at float. So let's okay, you see it's 0 because you have a double here, but you want to print int to like int. Okay, I know why, because 0 this calculation is not is not give you a float. Okay, let's do something else. Okay, let's do with a float. Let's try with float. Okay, the problem is not here. Okay, let's change here to %f. Okay, it printed well. So you see, if you don't respect the returned type, okay, if you don't respect the rule of the model function, okay, that's the model function, that's the child function. If you don't respect the rule of the main function, you will get a wrong result. Okay, you have to respect. If I write d, I have to get an integer, okay, because d displays waiting for an integer, so I have to pay attention to the returned type. Okay, you have a void returned type. When you have not to return, you can precise it by void. Okay, the type void don't return something. So like for example, I have a function will print directly a message. Okay, so I can just call this function. I can just call this function like that. So you have the same result. So this function is different than this function. Okay, print average is different because it prints directly. Okay, it doesn't return something. So a precise void because there is no returned value. So the value can be discarded. The returned value can be discarded. So it's like you call a function. Okay, let's do it. Okay, it is this case. Okay, the returned value is discarded. Okay, you have we have left the alternate. Okay, it's not this case. No, it's not discarded here. Let's do something like, yes, the alternate value here is discarded because you don't use the alternate value. Okay, so this value is lost. To make your compiler, to make it more comprehensible for your compiler, because in some case it's possible you'll get a warning, okay, in the console, but now I have not a warning, but it's possible in some case. To precise, you know what you are doing, you have to put a casting type with the function call. Okay, casting means conversion. Okay, you do void like that. So the average is supposed to return an int, but you don't catch it, you don't get it, okay, or you don't print it, so you have to precise it. Okay, it's better to do it like that, but sometimes with the newest version permits you to remove it. Okay, so I left it like that just for the video. And printf return the number of characters. So for example, we have many functions in C programming itself. Okay, we call it standard library. It is standard library. Okay, I don't remember, but I think it's standard library. There is a library called automatically. Okay, for those function, for some function, so we have many libraries and inside the library we have some function. We have already talked about it, I think. So for example, printf is a function has already code by somebody. Okay, so this function return a value, int value. Okay, you see the definition of the function. That is the declaration of the function. You have int, the name of the function, and argument. The first argument is const_char. Okay, const_char is a string, but we will talk about it later. Const_char is a string. This string value, okay, that is the first argument. Okay, the first parameter of the function, and the next function, the next argument many. When you put three dots like that, is to say you can put, it depends. Okay, it depends, you can put many arguments at next. So I can go, if I do right click, I can go to declaration of this function. Okay, that is the declaration. Extend, we will talk about it, but don't worry about it, just look for this. Okay, that's the definition. You can see the definition of the declaration, sorry, declaration of any function you want. Okay, you see the stdio.h. So VS Code has opened the location of this function. Okay, the location of the declaration. The declaration is in stdio.h. Okay, that is why we include it. Okay, then we see how we can to create our own header file. Okay, our own header file like that to declare all functions we want in our code or in our project. So this function returned an int, and this int is the number of character inside this parameter. Okay, the number of character inside this string. So if I try to do something like print, try to take, okay, just try it like that. Okay, 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 this is got okay, if I want to, I can I can take it inside the variable x, okay, or I call it number of character. So my variable number of character take the returned value by print. So this function do one thing, okay, it display this message in my console here, and then it return a value. So a function can do something like print in the print for a user, okay, in the console, and return a value in the same time. So let's print yes, the number of character printed is number of character, my variable that we have take from the printf. So the number of character printed is 7. So this character has 1 2 3 4 5 6, okay, 6, just 6, 7. If you count this character, okay, the backslash n is a character, so 7 character. If I remove it, it will be 6 character. Okay. Okay, that is it. I have 6. So escape character, we have told about it. It's a character. Okay, that is counted. We have 7 character. So there are many functions who can take the return value of that, and there are some functions that has not returned value. So it depends of the creator of this function. So let's show you something. Sometimes we define a function after the main function, something like we have the main at all my functions declare after the main, because when the user of your code, or somebody can come and read your code, you want to see the main function, okay, because it's here the core functionality of your code, okay. Those function is just it's secondary, okay, it's secondary. The main features, okay, the main functionality of your project is inside the main, okay. That is why many times we put the main function first, and then every definition is down. But if I compile like that, I get error, okay, I get a warning, but it's work, okay. It's work because the compiler can okay, let me do something. Let me remove the function. Let me remove it. I recompile. Yes, it's compiled well. It compiled well because the compiler, the newest version, can define it automatically. But normally it is not correct, because this function call a function that not exists yet, okay. There are no definition behind. So to make it correct, okay, that is why I have a lot of warning. To make it correct, I have to declare, okay. Declare function, I have already do it. We have already seen it in this, okay, layout, okay. That is it, function declaration, okay. We have to do it before the main function, okay. So we have to define average and print average, okay. Okay, we have not warning now. So declaration means like a prototype of the function, because the main function just needs about when you call a function like average, okay, the main function, your code just need the prototype of your function, okay? Just not the content, okay? It not need the content, but just the prototype, just the layout of the function, the function defined. So that is why my code can work just with it, okay? You take it, you can do your code, and then where the function call is doing, okay, inside the main, he go to find the definition down and go back at the main to to give you the returned value if they are returned value. So it means that I have the declaration, okay. I do a function call, but there are not definition here. So I go this calling go directly where the definition in the memory where the definition is doing. So it's not a problem if the definition is down or up. Okay, it's not a problem because the call function go directly at the line where the definition is it. Okay, so it has a prototype of your function, so it can go and search the same prototype in some definition you have down. It just check if the prototype is correct, okay. If it is the same prototype right here, okay, go directly inside and do the calculation and take the return, okay, and then go back at this line and continue the program normally, okay. It's a lot of knowledge, but with practice it become easy, okay. For now it's easy. So you have seen the layout of declaration. That is the layout of declaration. You can omit the name here, okay. At this level you can omit the name of the parameter. You can just precise the type of each parameter, okay. You can have int, you can add int, float, for example, okay. You just precise the type. You can have char, okay. But when you go to the definition of average, you have to precise it, okay. You cannot remove here because you have to use it inside this function, okay, inside it. So okay, I leave it for now like that. Array as argument. So I have talked about array. You can do something like that, okay. You can have an array, so you have to check it here. Very with int average. Okay, it's because the calculation. Let me create another function. So we create, for example, a function will do the sum int sum array, okay. I take array and the size, okay. It's important to precise the size because you cannot at this level you cannot know the size of the array you pass at like argument, okay. At this level you cannot know, so you have to precise manually the size of the array. So I can go to definition, I write the same prototype like that, okay. Same prototype at this level, you have to respect exactly the same prototype here, and don't forget the semicolon about the declaration. That is a declaration. I have to precise the semicolon, and for definition it's a opening, creatable, access and close, okay, because there are instruction, there are statements inside. So inside I I create a variable inside my function sum equals 0, and I browse the table with a for loop. Okay, the sum take the the current value inside the array, okay, the first element and then the second, and then until the size -1 of the table, and then return the sum. So if you put a size greater than the size of this array, okay, there will be a problem. There will be a logic problem. It's supposed to be a fatal error, but like C manage it, okay, but okay, let's try. We see it. I can call my function. I can create an array like that. Okay, let me put just a small space. I can create array. Okay, and then okay, you can calculate the size of array with. I have already shown you this formula. The size of array here don't give us the size of all the array, all each time each for each element, okay, times all elements. So like here I have 5 elements, and then the size of r give me 4 times 5, so I will get 40. Okay, I divided by size of one element, okay, to get the size of the array. That is 5. I have already talked about it to have the size, so I create a variable, I store it, and then I can call my function with the array, the concerning array here, and I precise the size. So I cannot do something like, for now I cannot do something like I call the array with the size directly like that. Okay, I will show you how to do it well, but for now we have just to do it like so. The declaration, in the declaration I cannot, okay, I can do something like I can put size like that. Okay, I can put size, but okay, it say me identifier size is undefined. Okay, that is why at this level I can show you the method to do it. Okay, I can show you the method to do it. Okay, I will show you another method. So for now we have to precise the size of the array and give the array itself. So that is the call here. Let's I have not to put this, okay, indicator. We will see more in manipulation of array, okay, at the later. Okay, you will understand how why we remove the square braces here and some different manipulation about array when we talk about pointer. Okay, because pointer is important to very understand array, the type array. So for now just take it like that. Okay, I thought that I removed the, so sum of I is 15. Okay, 1 plus 2 3 plus 3 6 plus 4 10 and plus 5. Okay, that is the purpose of this function. Okay, that is the calculation. It returns the sum. Okay, the sum is type int. Okay, the return type is int, and then when I call the function sum array, I get here this result. Okay, the returned value, this sum that is 15, and then that is why my message is sum of I is 15. uh, array, we can leave array for now. Return convert implicitly. Yes, I have talked about the conversion, the implicit conversion. When you return a type, for example here, return, for example, if I return, just for the try, I return a literal value like 12.4. Okay, that is the implicit conversion. Okay. um, okay, it's an implicit conversion. So if I compile I'll print average this at this level. Which function is it? Yes, average. The average. Why is not printed? Average of 3 and 6. I think I have found. It's for I have always for. Oh, okay. I have two returns. I think that is why I have to return. I want to show you just about this 12. I've returned a value. The value returned is a float. Okay, so but I waiting for a integer. That is why the decimal value is left. Okay, is removed to go in the same direction of the returned value. So the small parenthesis about it, so I can look. It was about conversion, implicit conversion. Okay, about the returned value. You can omit the returned type. Okay, you can omit the returned type of the main function. So automatically your compiler adds int. Okay, by default. Okay, you see I have not typed int, but I say int main anyway. Okay, the compiler adds automatically the int before, because by default we're supposed to return a integer value. That is why we have integer 0 at the end like that. Okay, by default. We will see about why we have to do return 0. Okay, let's and then we can do with any type. You can go with float. Okay, it's a function. You can do any return type, character, any you want. Okay, but by default it's int. Sometimes we can see in some source code void. Okay, void main to say I return nothing to precise it. Sometimes you can see this int main and void like parameter. Okay, for the next video we will do it, because when the difference by write nothing and put void is when you put void, you say at your compiler explicitly you don't need a argument in main. Okay, you will see the more reason about it, but it's better to do it, because if you leave it empty, when you execute, sometimes you can execute with some parameter. When you execute, for example this, I can add some parameter, so I don't remember how to do it. Sometimes something like arg, I think it's arg, so something like that, and add an argument. This type of execution add automatically an argument here when the executable file is doing. Okay, so by put void like argument like that, you cannot do something like that when you execute. Okay, it will not permit. That is why. So briefly, that is why we from now we will add the void inside like that. Inside we add a void like argument in the main function. mm, you can use excite. Okay, in English is excite. I think it's excite, the pronunciation. You can excite from a function by use return. Okay, you have to understand that return 0 has a role to excite the function, to the main function, but return is limited when you are inside another function like here. Okay, return just do a go back. Okay, we'll go back to the main function or the caller function. But when you use excite function, you close your excite function is for to stop. Okay, to stop your code directly automatically. So you have excite 0. 0 means the code has executed well, and you have 1. Okay, 1 is to say there is a problem, there will be a problem. So you can do something like you put excite here if you have to verify something. Okay, you have your verification here, and then if it's not verified, you can put here, for example, excite 1. Okay, for example. Okay, that's the example of the role of excite 1. Anywhere in your program, if and verification, okay, any verification was not respect, if a high level verification, okay, you can excite from your program directly. Or at this level, like we are inside the main, you can just use return. Okay, because we are inside the main. Okay, but if let's go back, if we are inside another function. Okay, for example here I can do excite 1 because it's another function, terminates the program immediately. If there are an error, for example in this function, okay, the program I have an error excite. Okay, I have to include stdlib. Okay, .h. Okay, it's a function inside the library stdlib.h. So I can, so my function has stopped directly at this level, print average. So let's move this at the, okay, before the array implementation. Okay, you see my code stop here. Okay, number of character about this I think yes, about this message. Okay, it stop here. Number of character is 7. After it, nothing, because I have called a function call excite 1. Okay, excite 1 go out directly from your program. But if I do just a return, okay, return is equivalent than excite, but it don't stop all your program. It just go to the caller function. The caller function is main. So let's try it. Okay, my code has continued after this line. Number of character printer is 7. Okay, I have another. So that is a difference about return and so I can just put in comments. That is a difference about return and excite. So uh, generally we just use return, okay, because excite is more used when we have specific verification, okay, to do, and if the verification, this specific verification is not respected, we use the excite function. And then okay, let's move to recursion. So without before to talk about recursion, I have an example to show you. This debug function called sum.c. I have created this file for show you how to debug a code. Okay, debug means look about the content of each variable of each of the stack. So the stack is when you call a function, the function the caller function in this case is its main. You call, for example, this function add. The caller function save many things like local variable, okay, the content of this variable, and then it save the address of the line where we call the function. So the caller say the code save all those information, and to see it we use the debugger, okay. I talked about it in the first playlist GDB, but we will not use it because we will have a playlist about GDB, okay, full playlist about it. So I want to not use it. But in VS Code, if you code in VS Code, we can go to extension and search those extension. C++, okay, this extension, and okay, those two extension, I try to install it. So you just type C/C++, you will see it. You will see it. Okay, these two, you can install the tree directly. It's important to have the debug, the debug about C programming, about C code. So when it's installed, you go to in here, run and debug, and go to the file where the file you want to debug, and click run and debug. Okay, that is just for show you how function call is doing. Okay, before to go to recursion, it's important to there's a problem. Okay, let's okay. I think for you, if you try the first time, you will not have you will have nothing here. You can take any debugger here, but the default debugger, I think the default debugger can manage any type of code. I don't remember, but you have to show it to take C++ disabled, okay, or another. I have take C++ GDB because it's installed in my. So you can have many debugger in your computer. I have Python debugger, so you have to install it before to come in VS Code and choose it here. Okay, when you go to run and debug, you choose, you take a C. Okay, you take any debugger about C++. So okay, firstly I have to make a stop point, okay. when you go at the line here, okay, line number, you have a small red point appear here. So it is to make a to add a breakpoint. Okay, so I want to add a breakpoint here, okay, at the beginning, and here at the function call, okay, to see you how the function call is work. So I can start, and my function stop at the next line, okay, because this line is not a statement. Okay, it is a statement, but it's not really a statement like like a really statement. Okay, it's just a definition of function, of the function main. And here you can see a call stack. So call stack is a stack. It's a stack that you store all function call. So the first call is a main function. Okay, it is automatically called. I have not called it somewhere like I have not called it like something like that. Okay, that is the form to call a function. Okay, but I have not do it. Okay, automatically this function has called it. That is just a definition, but automatically when I execute, this function is called. So my code stop at this breakpoint, and then I can do step by step, or I can go directly at this line. So firstly, you can go directly by continue. I think is yes, continue. When you click continue, it's go to the next breakpoint at the call function. So the function add is calling here with a parameter x and y. Okay, I put the value x is 10 and y is 20. So I put 10 and 20. That is so, and you have the current, you have all local variable. So local variable is the variable inside my function. Okay, I have x, y, and some has nothing. That is why you have a random number. I've already talked about it, so you have to pay attention. That is why I say it's better to do something like that. Okay, to initialize your variable. If you have nothing to store inside, put is 0. Okay, to avoid some problem. If you imagine you have to do a calculation with this sum directly after this line, okay, and you have a random value, maybe you have forgot to store something inside it. Okay, you have to pay attention. So let's finish the execution before to correct it. So I'm here, so to I can do step over. Okay, step over is to do, if you go, it's to go to the next instruction. Okay, to the next statement. If you do it tag, so my function has called and return the value. Okay, here the result, and directly is stored in the sum, and I'm in this line. So when I'm in a line like that, this line is not executed. Okay, it's when I pass this line. Okay, this line, but it is not executed. So I have a before function call already printed. Okay, it is this line, I have passed it already. So this line is not printed because we have not executed it yet. So if I do a step, okay, I go to the next instruction, this line is executed, so that is why I have my message after function call the sum is 30. Okay, and return 0. If I execute it, okay, it's the end, and then it's finished. So I want to show you more about it, so you can restart here the beginning way. I wanted to show you step by step. Okay, first step, okay, you have our variable with random value. So it's because we are at the beginning. Okay, this line is not executed, So let's go. Okay, I initialize by 10 here. You see the changing. Y here is changing, has changed. And sum, I declare sum, but I have not stored something, so I correct it before to continue. So I restart directly. Okay, you see a new value. Okay, it's random, it's very random. Next, okay, I have 10, and in y I have 20, and in sum 0. Okay, it's better to do it to avoid some error. And print, okay, print my value here. Okay, and now I'm on the line of the function. To see how the function work, okay, I do step into. Okay, step into is to go into the function call, into the go to the definition of the function to see how the function works. Okay, and step out is where step out is if you want to go out directly from the function. For example, I go step in, I'm here. If I want to go out, so I skip directly the next statement about this function. Okay, I do step out, but I want to continue normally. So now I am in the function. Okay, the function call. I have a local variable about this function. So result, okay, that is result has nothing for now because I have not executed this line. I have a, the parameter a is a local variable too. Okay, I have 10 because when I have called the function here, I have put x contain 10. That is why I have 10 store inside a, and then y has 20. That is why b has 20. Okay, so I have passed those value at my parameter, okay, in my for my function. So I can calculate the value now. So next step, I calculate, and then you see result has changed 30. Okay, I have 30, and then return the value. When I do return, in fact, I have explained it. Return give you the value at a specific register. So you have many register there, but I don't want to show you now. Okay, it's reserved for GGB playlist. So for now, it's not important. So just go to the next, and then I go back where I have left. Okay, where I have left. Okay, at the line, the next line where I have left my code. Okay, so the function call go execute, take the result and go back at the continuation. Okay, so I have not executed yet this function. I execute. Okay, I have after function call the sum is. Okay, okay, I have not shown you the changing of sum. Okay, sum okay, sum had 0, now it's 13, and the end returns 0. So that is how a function work. Okay, I can go more deeply, but for now it's okay. Okay, for now, because I cannot talk you about I cannot talk to you about register and so on. Okay, so this explanation is to introduce for recursion. Okay, recursion, you have this function factorial. Okay, recursion means that a function call a function call itself. Okay, like here I have a definition of factorial, and I call the same function inside the function. Okay, That is why you call it factorial. I have talked about it in the first playlist. So factorial of a number, that is the formula. Okay, n factorial is equal to n time n minus 1 factorial. So you have the function factorial inside the formula. Okay, to the two side of the equality. That is why it's a recursion. With the best case, so every time we have a best case, if you don't have it, I think it's a specific formula. But every many times we have a basic case because it's needed. Basic case here is factorial of 0 is 1 and factorial of 1 is 0. So base case permits you to stop your equation, because if you have not a condition to verify to stop your equation becomes a infinite loop. Okay, and it's not good. So firstly, when you declare a function with a equation, you have to put firstly the best case. Okay, the best case. So you verify if n is a number, if n is equal or more than 1. Okay, it's a so more than because we do the formula from 2. Okay, according the formula, okay, from 2, because we have said 0 equal 1 and 1 equal 1. That is the base. Okay, so if you have a number on the greater than 1, you can do those operations. Okay, the operation of factorial. So I print call of function factorial of the number. Okay, the first parameter is the number, the 2 point the number times factorial. Okay, so the formula number times factorial number minus 1. I just retake the factorial here and backslash n. So number is replaced there and number again is replaced there. Okay, that is just for print, so for a user, for you, okay, to see well how it's working. Recursive call, function call itself until best case is reached. So the recursive call is due until the best case is reached. So when I do I call the same function but with the parameter the number minus 1. So I call it again and again. For example, I have 4, I call with 3, 2, 1. When I arrive at 1 is the condition. Okay, so I skip this so it is a if else. So I go at else and do a return. Okay, just print. This print is just for you for see the result each time. So return means it stop here. Okay, it returns 1. The case of that is a best case. Okay, I have 1, so I return 1. Okay, because the factorial of 1 is 1. Factorial of 1 is 1. Okay, so I return 1 and then I go to the function caller. The function caller calculates with the returning value for the called. Okay, from the function called. It's difficult to understand now, but I try to explain with I can do now. I can go very deeply now because GDB I have not do GDB now. So okay, debug. I try just to explain you more with in VS Code here. So that is the declaration of the function itself. So the returned value is a long int, so a float. Long int is a long int, okay, not a float. Long int, because the value could be very large. Okay, factorial is a function will grow very quickly. That is why we return a value of the type long int to avoid to to get out of bounds error. So in the main function, I declare number for the number to do the factorial and the result. Okay, I say it's better to put 0 each time we have nothing to store, and print begin calculation. Okay, that's the beginning, the number itself. Okay, my variable number for my variable to do factorial, and then the result is the result take the returned value of the function. So I call the function here and take I store the results, I store the returned value, and I print end of calculation. Okay, that is about calculation. And then I print the result. So the factorial of my number is the result. So here is %lz because the returned value is supposed to be long int. That is why I have %lz. Okay, the format of long integer. So number come here. Okay, the factorial of my number is result. Okay, the result come here, and then I have where I have return 1 here. So if I try to just execute it normally with okay, debug function code. Okay, I can just execute here. Okay, it's better to execute. Okay, I have call of function for factorial of 4. Okay, it's 4 times factorial 4 minus 1, so 4 times factorial 3. So we have called factorial with argument 3. So we calculate it. Factorial of 3 is 3 times factorial 2. Okay, so I calculate this. Factorial of 2. Factorial of 2 is 2 times again and again. I take 1. The factor of 1 is 1 for factorial of 0, and then factorial of so I supposed to stop here because factorial of 1, I have the result. Factorial of 1 is 1, so I stop here. I supposed to stop here, but I think it's according this algorithm. You can do it differently. Okay, differently of that, but okay, we have a factorial 1 factorial. I've just take this code in AI, so that is why so call of function factorial 0. Okay, n is, that's the best case. Okay, return 1. So I calculate factorial of 1. Okay, stop here. Okay, stop here. Factorial of 0 is 1. Okay, so I have 1 times 1. Okay, I supposed to stop here, but I don't know why. Okay, anyway, I have the result here is 1. So here is 2 times 1. So the result of factorial 2 is 2, and then I've got 2. So factorial of 3 will be 3 times 2, so 6, and then I have the result of factorial 3, so I do 4 times 6, and then I have 24. So that is why I have the factorial of 4 is 24. So let's go step by step. I put a breakpoint here. Okay, from my function. I think it's not interesting to put it here. It's not interesting. Just at the beginning and the function call here, okay, like the last implementation. So I execute. Okay, my code stop here. The first, okay, I have my two variable with a random value. Okay, you see this value is very long than this value. It's because it's a type, is a long int type. Okay, I declare the result long int because the returned value of my function is long int, so everything has to be aligned. Okay, so I go to the next step. We're going step by step. Okay, number 4 is stored in my variable number, and then the next, okay, I store 0 to avoid fantasy value. So if I execute it, I print here, okay, beginning, okay, begin calculation, okay, it's a beginning, and then my function is called, okay, and my function print those information for you, end of calculation, and the factorial of 4 is, okay, and then the end. So let me retry by step by step about the function call. About the function call, okay, I go directly at the function with the continue. Okay, that is the function called factorial with my number. So I go to step into, okay, step into repair interior. I'm going inside my function to see how it's work, and then just step continue. Okay, it's verified. Okay, for now the verification is okay, and then okay, you see I skip the else, okay, because it's if else. I skip the else and I go back. Okay, my function is executed directly. Okay, to see more, I have to show you something, but I wanted to show you, but I have obligation to show you. When I run like that, I can show you the. I can go to this assembly view. So that is the view assembly view. Okay, this is assembly view. We will have a playlist about assembly too, so it's not important to understand that. I just want to show you how the call is work, the function call, the recursive call is work. So I go step by step. So the step by step here is different by the step by step here, because one function, for example, to print a function, I think we have 5 line here or 6 lines, something like that. So if, for example, okay, we have that is a declaration of number. Okay, I think if I go step, okay, 4, this line is to store 4, like you see 4, to store it in this variable. Okay, I'll explain you more, but for now that is my variable. PTA is a represent number, and result, okay, result is store in PTA to PTA is a register. Okay, but it's divided in two. I can say just like that for now. It's divided for number and result. So next thing, okay, this part is for print, I think. Okay, let me do something from here to here. Okay, you can see a print f here. Okay, that is a call. Okay, we call the function, okay, the reference of the function print. So just to print, we have 1 2 3 4 5 6 7 line. Okay, that is why assembly coding is very hard. Okay, it's not difficult, but it's hard. To just do one thing is complicated. So that is about the printf. So until I go until call. Okay, I go through call, okay, we see it's printed, and then after the call we have function. Okay, function call. So the function call himself itself is, I think, is 6 line. Okay, let me give you the range from here to here. Okay, that's the function call put arrobas. That's the no, I think it's here. Okay, here what's happened here, I store some variable. I store all my variable inside the accumulator, and then the accumulator store inside the stack. Okay, not it's not really a stack, it's a register, it's another register to store the the context. Okay, the context is those two variable. Okay, I have to store it, and then I store the line, the returned, the address of the line, of the returned line. So it is this line. Okay, I have to store the address of this line, because when I have finished with the execution of this function, I return at this line exactly. Okay, to continue normally my code. So that is about the function call. So I go, okay, this line is to call, you can see factorial. Okay, it's the name of my function, it's the label of my function. So call tag. Okay, best case reach. So I am already, okay, I think it's just a comment. Okay, just do the next. Oh, okay, I think it's here, the call is, okay, let's just do next. Okay, okay, I have to do step into at this call line. So let me restart. I want to show you exactly what's happened inside the function call. So I go directly at the, okay, and do step into. Okay, that's why I want to show you. Okay, okay, it's not okay, let me retry. I want to show you something. This video is long, it's very long. I finish soon. Okay, I go directly to the function call factorial, and then I go to okay, here, right click and open this assembler view, and then I do step into here. I want to show you something. Step into, okay, again. Okay, I've do a jump. Okay, let me show you. That is the function call. Okay, call factorial. I've do a jump to this line. Okay, that is why you have here for factorial. Factorial is the current function executed. Okay, I'm not in, I'm not, I'm no longer inside this function main. Here actually I'm in this function. Okay, before I skipped it because the step here is different like the step here. That is why we have step into, because if you do just step over, you just go directly. Okay, you just go under the function call. So I go from here. Okay, well, there's the function. I go from here to here, because the code of my function is up. Okay, it's from here to the to I search the return function, the return Okay, let me check. Okay, if I continue, which will be equals. Okay, let's just continue. No, put some more as the execution of my function is executed, and then I call. Okay, this call is to call the function itself. Okay, I think I think it's this instruction. Okay, I think. Okay, let's check. Okay, I don't see it. Okay, that is happen is because we cannot see it here because function call the create a double is look like a double of the factorial function. You see here print f arrobas plot. Okay, it is the same function. Okay, it's the same function. The function has double itself. Okay, and create another new instance of it. That is why recursive is use more memory. Okay, it's use very more memory than iteration, because I've explained that recursion is look like exactly like iteration. Yes, iteration is loop, for loop. This code, any factorial code, you can do it. You can do the same thing with a loop. Okay, with while loop or for loop. But factorial, it's better when you have a typical type of factorial like that. Okay, but many time for loop is very fast. Okay, faster than factorial. Okay, so just use factorial when it's very just to make your code clear. Okay, let's continue. Yes, let's just continue. Uh, oh, whoa. Okay, I have do a mistake. It's because I'm going inside the printf function. Okay, that is why I saw print. Let's retake. It was just, I think is I'm tired. Okay, I'm going to a function call. Okay, and then I go to, okay, let's go step into. Okay, I can check open this is assembly view. Okay, I'm here, so I have to do normal step. Okay, step over to traverse printf, because if I do step into printf, I go to the definition of this function. Okay, that is why this cursor, it was not here, it was at the definition of the printf function. Okay, at the definition is, I think it's inside this file. Okay, it is another file, so I want to just traverse it. Okay, from now that's the recursion, so let's go now. I think I don't need to do step into here now. Okay, just step over. Okay, that's about my function factorial. I do, and then call factorial again. Yes, I'm already at this line. I'm always at this line, and then okay, I'm at the end. My function is executed. Okay, I cannot show you well with this tool, I think. If I do step into okay, let's just return. Okay, I'm here. So they call again. Okay, to go inside again, I do. Okay, you can remark that I have not take the next line directly because this function is calling again. Okay, it's executed again. That is why I go. No, it's not. Okay, it's not. I think I can stop here. I cannot show you exactly how it works, but if you have understand this, okay, the function call itself with a new parameter. Okay, the parameter is update sharp each time you call the function, until to reach the condition, the best case, and then we go up, okay, at the another okay, inverse, go at the inverse sense and calculate until you reach again your until you get your result. I think in the playlist GGB, the debugger of C, maybe I could show you exactly how it works in memory, but I cannot show you it now. Okay, I cannot show you now, so make your patience, and the video was very long, so it was I'm very tired, so I need to go to eat and sleep. So take care of you, Nakama.
Je fais le portrait comme au Beaux-Arts, loyal, poli, droit et sincère. Je respecte le code du Bushido. Mais si on met les armes à terre, c'est pour te faire une prise d'aïkido. Et la concurrence au cimetière, ne pensez pas mourir aussitôt. Mon katana taille leurs artères et broie leurs organes génitaux. Quand j'étais gauche, j'en ai pris des coups, j'en ai dans le ventre comme un seppuku.